Scenario: a student stands on top of a 50.0 meter high tower, launches an object in an unknown mass 30 degrees below the horizontal, such that it follows a projectile motion. Question: graph the following motion graphs. The first two that they would like you to graph is the vertical velocity component, then the horizontal vertical component. This should follow the same thing in your textbook as a projectile motion off a cliff. If you take a look at the horizontal component, which is the arrow going left to right, notice that it is the same size and it is positive. So the graph should be linearly, it should be constant, and the y-intercept should be positive to demonstrate that it has a positive value. The vertical velocity component, take a look, that is the arrow that's going up or down. Notice it's pointing down in the negative direction, and that arrow is growing in size. That is why it is linear, to show that it is growing linearly. It has a negative slope because the size of it is going more and more downwards as time goes on, and it has a negative y-intercept because it has a negative value pointing down. If you would like to calculate it, the formula would be the velocity in the x direction would be the velocity naught cosine theta. The velocity in the y direction would be velocity naught sine theta. The next part, it asks you to graph the vertical displacement, which is height, delta y, or h for height, and then the horizontal distance, which is delta x, or d, right here. The horizontal displacement, it is linearly positive slope with a 0 y-intercept, because here it starts off at 0 and it increases linearly as time goes on. Vertical displacement, notice here it starts off at that 50 meter cliff, so this should be the 50 meter height of that tower, and notice it is decreasing linearly. So it is linearly negative slope and a 50 as the y-intercept.